So here's a hypothetical, right? If marginal costs were decreasing, well, if marginal costs were more than average cost, what do you expect would be happening with average cost? Do you think it would be getting bigger or getting smaller at that time? So if marginal cost is more than average cost, then average cost should be, what do you think? Increasing, decreasing, staying the same? What do you think? What is marginal cost measuring again? Yeah, it's the cost of the next unit, right? So if average cost were less than marginal cost, right? It's costing me $9 per unit right now, but the next unit is going to cost me more than $9. What's going to happen to the average cost overall? Get bigger, get smaller? Don't know. Yeah, it should be getting bigger, right? Yeah. So if it costs me $9 to make $9 a unit now, but the next unit is going to cost me $11 to make, then the total cost, right, will have gone up by 11 instead of 9. So the average cost should be getting bigger, right? So average cost should be increasing. Okay. If marginal cost is less than average cost, so if it costs me $9 a unit on average now, but the marginal cost is $2, what will be happening to the average cost in the future? It should be getting smaller, right? Right now it's costing me $9 a unit, but the next unit is only going to cost me $2. So when I average that in with their other ones, the average cost should be decreasing. So in general, we're expecting average cost to decrease and then to increase. Right? We expect that average cost decreases, then may increase. Right? We're expecting it to do something like this maybe. It's certainly got to decrease at the beginning, because the more things that you produce, the more units you're spreading that fixed cost over. So we're expecting that there's going to be a minimum. And that is an interesting time for us, right? So on average, we're going to be perhaps interested in having as low of an average cost as possible to make the number of units, so that our total costs per unit are low, so that our margin of profit is going to be higher, right? All right. So, there's got to be some time then when the marginal cost stops decreasing and starts increasing. So how do you suppose you could find this time? What's the marginal cost going to look like at that time?
Very close to the average cost.
Yeah, it should be like almost exactly the same, right? So if it costs me, if on average it's $9 now, and the next one's also going to cost me $9, well then the average cost isn't going to change, right? If the marginal costs were more, I would be expecting the average cost to increase, and if the average costs were less, I'd expecting it to be decreasing. So if it's neither, then I must kind of be in this twilight zone where I want to be, right? So that's an exciting fact, right? Average cost minimized when average cost equals marginal cost. We might put it this way in symbols. We move over, right? So the average cost is minimized when the average cost is equal to the marginal cost. So C bar of Q equals C prime of Q. Okay. Does that make sense in general? Solving this equation is going to be a lot easier potentially than finding the derivative of C bar, right? Because remember, C bar, I'm dividing by a Q, and dividing right now is not maybe my favorite thing to do when taking a derivative. Maybe in the future, right, I'll know how to handle something like that. Because this is also a time, right? I also know this fact, right? That the derivative of the average cost should be 0 at that time. Okay? Oh, look, here's the average cost function. The slope of the tangent line is 0 when it's minimized, and the slope of the tangent line is the derivative. So if I took the derivative of the average cost function, it would be 0 at that minimum. But dividing by Q and then taking a derivative, maybe that's imposing to me right now. Seems like a lot of work. Whereas these are easier to find, and I can just set them equal to each other and solve. So these are kind of two ways about it. Right now we're going to be kind of focusing here because it takes a lot less work to be able to set up this type of equation. Solving equations in general like this, though, might be difficult, but equations here might be difficult too. Questions about this fact in general? All right. So that's fun. So there's that. The other thing that I might be interested in is this idea. Linear approximation. All right, so here's an idea. Let's say C of 1,000 is $9,000, and C prime of 1,000 is $2. And now we're asked to approximate C of 1,003. Anybody have a good guess? What is C of 1,003? What am I actually asking for here in terms of yeah, so this is the cost of producing 1,003 units. That's exactly right. So this is the cost of producing 1,000 units. 1,000 units cost me $9,000. I want to know if I make 3 more, what's the total cost going to be? What other information do I have? I know that C prime of 1,000 is 2. What does this tell me? Yeah, so this is the marginal cost at 1,000. It's telling me that the next unit is about $2. So if I wanted to add 3, what do you suppose that the total cost is going to be? About 6, right? So this should be 9,000 plus 3 times 2. So $9,006. You suppose that's a pretty good guess? How good of a guess do you think that is, really? Certainly it may not be exact, right? Maybe like maybe the 1,001st is going to cost me $2, but the 1,002nd is going to cost me $1.90, and the 1,003rd is going to cost me $1.80. I don't know. So it might not be exact, but it's probably pretty close. What if I wanted C of 2,000? Do you think it's going to be a good way of approximating what C of 2,000 would be? Why not?
It's too far away from the base.
It's really far away from where I am now, right? There are a lot of different things that the marginal cost could do in between there.
You
Right.
may have to like hire more people, or add more equipment.
Yeah, I could need more equipment. My efficiency could go down. I could need a larger space. There's all kinds of different things that could happen with a function, right? In a small little window, right? If this is C of Q, right? And here's 1,000, and then 1, 2, 3. Here's 1,003. Okay. In a little window, I'm expecting the rate that this is changing at not to change very much. Okay? Basically, what I'm doing is I'm saying, right, this $2 is the slope of this tangent line. I'm saying that I think that this slope is going to be fixed for 3 units. So what I'm doing is I'm guessing that, 1,003, that's going to be here. So these dots are pretty close together because I'm in a little window around 1,000. But if I went way to the right, I've already come 1,000 over. If I just doubled the amount, right, who knows, right, how different they might be. They could be very, very different. Right? So this is great on small scale. So if I only know what my current cost is and how fast it's changing at this moment, I can figure out costs around me without knowing exactly what the cost function is or exactly what the marginal cost function is, right? I'm just given like these 2 little blips of information, and I might be able to tell, I'd have a good guess for what it cost me to make 999 units or 997 units or 1,005 units, right? Because I'm using this line to kind of guess around it. I'm saying like this line is a pretty good guess for what this curve looks like in this little window. But if I tried to broaden that window, the cost function isn't a line necessarily. Right? All kinds of different things could happen. And so the line becomes less of a good guess. It's pretty straightforward, right? Not a super complicated concept. All right. The author of our textbook, he gives kind of a complicated formula here. I am not going to repeat that formula in your notes. Right? Here's the concept of it. I think that this kind of like walks you through exactly what's happening pretty easily. And I don't want you to kind of get confused in the symbols because the symbols kind of suck. But if you're a formula person, feel free to use your textbook. I've got one open here. It's on page 150 if you're super interested. It's It's like f of delta plus, or f of q plus delta q, something like that. Too many symbols, I think, but for a really basic kind of concept. Seems okay?